This video is about the decision tree ID3 algorithm, and we are Team 6. The purpose of ID3 algorithm is to assist people in making the best decision for problems that have several solutions or contain several nested decisions. It generates a decision tree from a fixed set of data, which is then used to classify future data. Decision trees contains leaf nodes and non-leaf nodes. Leaf nodes contains the class name and non-leaf nodes are decision nodes and is an attribute test where each branch is a possible value of the attribute. ID3 use entropy and information gain to decide which attribute goes into a decision node. It removes the need for an expert to manually create a decision tree.
In 1975, Quinlan invented ID3, but this algorithm has some limitations. It didn't consider how to deal with continuous attributes, missing attributes, and noise. Subsequently, Quinlan designed the C4.5 algorithm for the deficiency of the ID3, introducing the concept of information gain rate. It overcomes the problem that ID3 can't handle missing attributes and continuous attributes, which makes the algorithm more efficient and more applicable. CART is another algorithm invented in 1984 for both classification trees and regression trees.
So some common applications of the ID3 method include stock analysis, disease prediction, which uses attributes such as symptoms and location to predict diseases in patients, purchasing behavior rules in sales, credit risk assessments, which could use attributes such as debt and income, and web search classification.
Information in decision trees depend on feeding precise internal and external information at the onset. Even a small change in input data can sometimes cause large changes in the tree. Changing variables, excluding duplication information, or changing the sequence midway can lead to major changes and might require redrawing the tree. Among major decision tree disadvantages are its complexity. Decision trees are easy to use compared to other decision-making models, but preparing decision trees, especially larger ones with many branches, are complex and time-consuming affairs. Decision trees can also be unwieldy. Even data that is perfectly divided into classes and uses only simple threshold tests may require a large decision tree. Large trees are not intelligible and pose presentation problems. The complexity in creating large decision trees mandates people involved in preparing decision trees with statistical analysis. The costs involved in training people to complete a complex decision tree analysis makes decision tree analysis an expensive option, and remains a major reason why many companies do not adopt this model despite its many advantages.
So some major limitations of the ID3 model include the possible overfitting of data. To avoid this, we tend to prefer smaller decision trees. It's also hard to classify continuous data, as you need to decide where to break the data set in order to create different branches of the decision tree. Small changes can also have a large effect on the outcome of the final decision tree, and there's also not a guaranteed optimal solution.